All right, ladies and gentlemen, this is generally the most confusing part of this unit. Yay! But we're going to make it unconfusing for you. So we're going to determine the solubility of products. We were talking about double replacement reactions yesterday, and we said what happens is the cations change partners. So silver partners up with chlorine on this side, while sodium partners up with nitrate on this side. So it is a double replacement do-si-do reaction. And frequently the end result of a double replacement reaction is a precipitate is formed. A precipitate is an insoluble solid, and we use the abbreviation S to mean a precipitate or insoluble solid has been formed. Your job today will be determining whether something is a solid or an aqueous, which means dissolvable, compound. So here's what we do. We're going to use the solubility rules, and they're organized by anion. Let's look right here for right now. If something dissolves, you might want to write this down in your notes. If something dissolves, we say that is aqueous. If something, and another word for dissolves is soluble. So both of these things, you would write aqueous and you would abbreviate that AQ by the product. If something does not dissolve, we call that insoluble, and we write S for solid next to the compound. Okay, so we're going to do a couple of practice problems, or practice compounds here, and we're going to determine whether they dissolve or they do not dissolve. And we do this by looking at our solubility chart on our green sheet of happiness. Ready? Okay, find your solubility chart on your green sheet of happiness. I found mine. Right here. Okay. Now this is the difficult part of your solubility chart. First of all, it's listed with the anion first in almost every case. Not all, but almost every case. So the anion in a compound has the negative charge, correct? Yep. So you'll see almost all of these have negative charges. The exception is right here. This is the ammonium cation. It is positive. So when you're trying to figure out if something is soluble or not, you look to the anion in every case except this one. If the anion is under the soluble list, what does that mean? Dissolve or not dissolve? Dissolve. Dissolve. What would you put next to anything that dissolves? AQ. All right, so let's see how this works. Boy, it does not like it with the green, does it? All right, but we'll soldier on. Our first compound that we need to check, it's in your notes, is silver chloride, AgCl. So we look for the anion in AgCl. It is the chlorine. We look in our list until we find it. Chlorine is soluble except when it's paired with, and then it says, compounds of silver, lead, or mercury. Let's say that again. Chlorine is soluble unless it's paired with silver, lead, or mercury. Ours is paired with silver. Is it dissolvable?
No.
No. So we would put an S next to it. Now let's look at our next example. Potassium nitrate. We look up the anion. There it is. Nitrates are soluble when paired with everything. So it will dissolve, and what would you write?
AQ.
AQ. Let's try to find lead 2 sulfide. I'm looking for the anion, which is the sulfide, and it's not in the soluble category, but it is in the insoluble category. In the insoluble category, what would you write next to it?
S.
S. Okay, I found sulfide, and it says it is insoluble unless it is paired with ammonium, the alkali metal cations. An alkali metal cation is otherwise known as a group 1 cation. Only those in the group 1, not group 2. Those are called alkali earth, just group 1. So sulfides are insoluble unless they are paired with calcium, ammonium, all the group 1s, calcium, strontium, and barium. This is not one of the exceptions. Is it soluble? No. So you would write S. Moving on. Alrighty. Let's try some more. Alright. Here's a shortcut for you, a memory hook. Just jot these down under soluble. Make yourself a list. All group 1 metals, all nitrates, all acetates, all ammonium compounds are always soluble. Always. You know what? In chemistry, I get to say always about 3 times a year. This is one of them. So write down your always statements. You should watch out for half. Half means mercury, silver, and lead. Those compounds are usually insoluble. They have very limited solubility. What happens if I have a compound, I don't even know if this exists. If it existed, I would call it mercury 2 acetate. Would mercury 2 acetate be AQ or S? It would be AQ because all acetates, I don't care what it's paired with, are soluble. So it would be AQ. Lead 2 nitrate would be AQ as well. All right, take 3 minutes and just make a list, AQS, AQS, for these four. By the way, that's not how they go. Those are not the answers. Ready, set, go. I don't care where you write it. Write it on your neighbor. Look. What does this spell? Nacho. Write them down. Am I right? Yes or no? Yep, I think I'm right. Okay, let's go back and look at this experiment. Or just wait for the circle of life to continue on. There we go. All right, I have three compounds. All of these are aqueous when they start out. How can I tell they're aqueous? Because they're solutions. All right, I have sodium chloride, silver nitrate, and potassium hydroxide. I am going to make a double replacement reaction by mixing them together. I'm going to start with sodium chloride and silver nitrate. This is what's going to happen. I don't have anywhere to write so you can see my writing, so I'm going to write the equation on the Erlenmeyers. Sodium chloride will mix with silver nitrate, and they will exchange anions to become sodium nitrate and silver chloride. Look at your solubility rules right now and tell me, will either of these form a precipitate? Raise your hand when you have an answer. Raise your hand when you have an answer. Okay, ladies and gentlemen, what is the answer to the question, will a precipitate form when the two solutions are mixed, yes or no?
Yes.
Yes? What will be the new solid out of these four choices? AgCl? Was she correct? Yep. There's Ag and the Cl floating around, and it goes to the bottom. Nicely done. Let's try silver nitrate and potassium hydroxide. When they mix, silver nitrate plus potassium hydroxide will yield silver hydroxide and potassium nitrate. You should know that all nitrates are soluble, correct? Mm-hmm. So you just have to worry about silver hydroxide. Look on your chart. Will it precipitate or not? Who says yes? Who says no? What happened? I think this is the no part. I don't know. There we go.
Is one.
All right. Yes or no? Yes or no?
Yeah.
All right. Which one? The silver hydroxide? This? Yeah, because. And the last combination that we could make would be sodium chloride and potassium hydroxide. What are the cations in both of these? They are both group 1. Any mixture of a group 1 cation will be aqueous. It will be soluble. So these trade places, we have KCl and NaOH. Will it precipitate form? Nope. Nope, just ions hanging around sometimes.